Mediator design pattern solves the problem of many components talking directly to each other. One simple example is a single web page, for example a checkout page where we might have three components, a shipping form, payment and summary component. All these components need to somehow coordinate to give good user experience, like if a shipping form is not properly formulated, a payment form needs to be disabled, and if payment form changes something, then a summary needs to be updated. If we would just allow all components to talk to each other directly, we can quickly see how this becomes very difficult to maintain, and all components become connected and coupled with all other components basically. So when we add new component, it becomes even more difficult to orchestrate this mess of interconnections. This is where Mediator comes in place. It will coordinate all this communication and every event and all data that goes through it. We can find the Mediator pattern or something very close in many places. In dashboards, filters and graphs update together, and in forms, it can coordinate input elements, which is an exercise that you will actually do on your own in the Skill Builder module later. Even frameworks like Vue or Angular have the event bus or what's called the service layers, which act as a mediator between components. And this is especially powerful in large applications where multiple parts of the system needs to interact, like maybe form and loaders and data fetching, which affects UI state or dashboard filters, updating, multiple widgets at once, and things like that. With Mediator, the components don't even need to know about each other anymore. They just talk to the Mediator. This means we can change, replace, or reuse parts of our application with little adjustment. Now this pattern sounds a lot like an observer, or maybe like a controller, but the difference from observers is that, in observer components are meant to interact and organize flow on their own. They should just observe each other and do their own things. Whereas with Mediator, I always mispronounce that, will take the active role in making decisions, and it can sound like a controller pattern here, but controller actually has views and models to work with, whereas Mediator is independent of the UI. Main benefits of the Mediator pattern is decoupling. The components don't talk to each other directly. This makes them easy to reuse, test and maintain. It is also centralized logic. All communication logic is handled in one place, which gives the Mediator a better control over our app's behavior. And extendability, we can add new features or components without rewriting the existing one. We just hook them into the Mediator and we're good. But of course, there are some trade-offs. First is complexity, like I think with any design pattern out there. For small apps, introducing a Mediator might feel like an extra work if you actually don't need it, and it's mostly useful to medium to large application. Debugging could be difficult. When all events go through one object, it could be tricky to trace who triggered what if we don't have a good control over our code or if we're not logging properly. There is also a concept of complexity shift. Instead of many small dependencies that are easier to work with, we can now have one big dependency, the big chunk of code, the Mediator. It needs to be clean, well-structured and predictable. So the Mediator design pattern is a powerful tool for organizing communication between objects and components in JavaScript applications. Here we have one real-life example that the Mediator pattern could help us solve. In this case, we have a shopping cart for a website, and this is the first object here with some methods like add item and calculate total. And the second object is the inventory, which holds the track of total, inventory, the stock that we might have in our basement or wherever we are selling it from. And there is a third object, which is this payment method here, the payment object, which has the update total, but it could work with other things like payment fees and, shipping and things like that. So what are we here doing in the application is that we are adding an item to a cart. At the same time, we need to decrease the stock in the inventory. We need to update the inventory so that the new visitors on our website would get the updated stock information. And of course, we need to calculate the total for this payment so that it is correct. Now, this is really straightforward here. I'm just calling it here in our application, in our main controller. But you can see how that when we add another item to this cart, we then need to decrease stock again and update total if this is going to happen from some other place, from some other product or some other page in application. But also if we would to remove item from the cart, we would then again need to increase the stock value and update the total. And well, obviously this code needs to live somewhere. And it's very difficult to find a good home for this chain of things that need to happen when we add, update or remove an item from the cart. If we run this from browser, we can see that the cart has 2 items, the inventory has updated the 2 items total, and there is a total for the payment as well. Now, this code would have to live somewhere, and it's very difficult to find a good home for this chain of things that need to happen when we add item to the cart, we remove item to the cart, maybe we just update the total. So the easier thing to do here is, well, we could just amend our cart here so that in the constructor it receives both the inventory and the payment objects, and then we can just store them into variables. But then here, after we have added the item to the cart, we could just decrease the stock and update the payment here. And this would work just fine, but it's easy to see that here we need to do something when the item is removed, right? So if we have the remove item from the cart, we also need to decrease the stock and to update the total, and also to worry about the items where we're going to remove the item from this. And suddenly there is again this duplication here, and we can see how this will just start growing. And it's maybe better to just keep it duplicated somewhere in controllers rather than polluting the cart with worrying about some other thing and putting dependencies on it and having the cart to worry about all the other things that are not its own responsibility. Say maybe we need to a discount component here to calculate the discount somewhere in the between, and suddenly our cart becomes way too complex and has to do much more things than it's actually supposed to do, and that is keep track of items in the cart. So in this case, the cart would become some sort of controller, and we obviously don't want that because we are then tightly coupling the cart with every possible other object in our application. It's very difficult to test the cart and to expand it in, especially in isolation. There could be also a risk of circular dependency, meaning that at one point the discount might update the cart and the cart might go back and try to get something from the discount, which would then update the cart and so on, and going in circles. So this is very difficult to keep track of who is doing what and where all the logic is being handled. This is why we need a centralized place to control what is happening when we add something to the cart. Another approach that could be tempting is to pass a callback function here. We could just have a callback here on the add item, and instead of calling this directly, we would just call this callback and execute it immediately here. And then down here in the controller, when we are adding the item, the second thing would be a nameless function where we could say that we could just decrease the stock in the inventory. This could work just fine and it looks a bit cleaner, but it doesn't do much good for where this actual callback function will be stored. We still need to put it in some sort of controller, some centralized place, or in some initiator, and suddenly it's not a centralized place that controls this logic. Now think of how would you solve this problem where we need to have several things that are happening at the same time. In this case, adding an item to the cart, updating the inventory and the payment, so that they are not depending on each other and they don't know about each other, but at the same time, when we're not duplicating this code each time an item has been added to the cart. And later in this lesson, I will show you one way of handling this, obviously using Mediator. Let's look at one real-life theoretical example where Mediator pattern can be used to solve a problem. Now here we have a e-commerce application, something that we've probably seen somewhere on the internet, and we have 3 types of filters and a list of products. We have a category filter here. You can imagine this being an universal online shop with many categories like electronics, books, clothes, vehicles, etc. Then there is the price filter with some values, and there is a brand selector where you can filter and choose by the brands that you want to buy. Now, obviously, there is a mismatch or connection between these filters where they could react to each other. So if we would to change the category filter, it would filter some price options, because some books, if you choose books, there is usually the top price that the books go for. There is also some different brands that you can select. And this means that each time we change a category filter, we need to orchestrate that change to the both brand selector and the price filter as well. So when we choose something in the price range, in addition to the category filter, we need to again make that coordination to all other components as well, so that the list of products is displayed properly and all the filters are synchronized, ensuring that we don't end up showing something that's non-existent in our inventory, and at the same time offering some choices to our customers. And we can already see the problem here. The problem is that these components need somehow to be interconnected. They need to communicate with each other, and they need to react to each other, so that when the category is selected, the price and the brand are being updated properly. If we keep that code in each and every component, it will soon become very difficult to maintain, because every component will do a bit of logic and then everything will have a bit of everything. And if we add another filter, it would become even more mess than it is. Now, there are multiple ways to solve this. We could solve this with a state pattern. We could use observer, maybe use a command pattern here. While they all kind of look the same, the observer is obviously about one component observing other or multiple others, whilst here everybody would observe each other, so it would at the end become very tangled. And there is no point of us of uninstalling or removing some filters programmatically. The state, on the other hand, is not about coordination, but a change in behavior, and the command pattern could be potentially overkill here, because we would need to have a command for each and every possible option here. And you can go back to previous lesson, previous modules, and try to figure out how could you solve this problem with maybe some other design patterns. You might probably find a good solution. But today we're looking and going to focus at Mediator pattern. Mediator, I always pronounce it bad, I apologize for that. The main benefit over the other design patterns is that the Mediator pattern takes control over what these components are going to do. So the Mediator pattern would take the responsibility of coordination and passing actions to all components, or passing information to all components, and maybe some configuration as to what they should, in this case, filter. A Mediator would contain some logic that will tell the maybe brand selector which ones should be enabled and disabled, and do the same for the price and the category, and as well the products component maybe. It could also update the UI, indicating that one product or maybe 5 or 10 are being shown out of the entire inventory, and it could update the pagination, things like that. So it would take the additional responsibility of, well, mediating the communication and controlling these components, and making sure that our filtering logic has one single place where it lives, so we don't have to go through all components and figure out what's happening if some of them changes. All that logic is being contained or handled here in the Mediator object in this example. In this video, I will show you one way of solving our cart payment. Here I will show you one way of solving our cart inventory and payment synchronization problem using the, well, obviously Mediator design pattern, or is it Mediator pattern? The way I would solve this with Mediator is by adding another class which will take all these dependencies and cart inventory and payment in a construct. So I will just remove this callback here as an attempt and clean back the cart so it doesn't care about anything else. Remove this callback as well, and let's make a new class that I will creatively call Mediator, and in constructor it will receive all three things that are relevant. It might not even receive them, it can just make them, for example, where this cart would be a new cart, and the same to the inventory, and the same for. And then I will make another method called add item to cart, which will receive the item in question, and here it will be the same as cart add item. So I will just move these actions here, these add item, update total, and decrease stock. Just remove this for now, comment everything. And I need to prepend with this because we are now creating these objects inside the Mediator itself. And now this is pretty much all there is to Mediator. It is just a place that can consolidate some dependency and some logic of some operations of things that need to happen. This is an orchestration in some case of some events, in this case adding an item to the cart. But let's call this and run it, and I will quickly go through this code to show how it works. So now here at the bottom, instead of creating all these three objects here, we are going to create a new mediator, and then we are going to add item to the cart as we tried before. In this case, I will just take this item here, and I would rather pass this item from here, and I will put this item to the cart here. Now, if I would to run this, we can see that cart is not defined on line 34, and that is because I should call this cart, and now I can console log the cart from the mediator. So console log mediator.cart items, just like we did below. Try this now. We can see now that we are accessing this item from the cart. There is one item that we've added. We can probably add another item here, just like we had before. So item number 2 is of price 50. And we can see that we still have 2 items in the cart now. Let me just console log the inventory as well and the payment total. And we can see that in the stock, this has been changed to 9 and to 4. We started with 10 and 5 of these in the inventory. Now they have changed, and the payment total has been changed to 150. So all the functionality is there. And let's quickly run through this code to see what has happened and how have we changed this. So now, instead of orchestrating all the things that need to happen when item is added to the cart, we have put a mediator which will take responsibility of orchestrating all that part for us there, so that when we add item to the cart, well, actually when the mediator is being created, in the constructor here, we will get all dependencies, all the participants in this event, and when the add item to the cart has been dispatched or called, the item will be added to the cart, the inventory will be decreased, and the total would be updated. Now we would probably have some method for remove item to the cart from the cart, right? And here we would increase back the stock and we would update the payment, but we could also have another method for apply discount or maybe remove discount, give the ticket code or something like that. And these methods would be centralized here in the mediator. This could probably be called the payment or shopping mediator, and they will actually do what needs to be done for us. And here we can see some of the benefits that we talked about. First is decoupling. Now these components, the cart, inventory, and payment, do not talk with each other. They don't care about prices or anything like that, and inventory does not care about what's in your shopping cart, if there are 5 users shopping simultaneously or not. This makes it very easy to reuse one of the components and test this inventory on its own, maybe use it in some other systems. And it also makes the centralized logic here very convenient, because all the logic for adding an item to the cart is, well, nicely organized here, and this orchestration of this event is handled in one place here in the mediator, which gives us very good control over our app's behavior. We can also just add new features, add new components, do something else that needs to happen when the item is added to the cart, and just orchestrate that, what's going to happen each time we do that, because we can just hook them up in the mediator and we are good to go. You can also see some of the trade-offs, like a bit of additional overhead, where just for small functionality we actually had to make additional class and new methods and probably new files and things like that. For simple examples like this in small applications, we probably don't need this mediator here. We can just call whatever needs to be done where it needs to be done. However, when we see that this is something that could benefit from Mediator, that's why it's important that to learn them, we have that tool in our tool bag and we can just use it and apply it here. Now, this Mediator could be a bit difficult to debug as well, if these methods would to grow much bigger. And this mediator also has a tendency to become the God object, something that has just accumulated all possible logic in the entire application. And people usually start putting a lot of if-elses there, a lot of business logic there, and different ways of adding items to the cart when they're stressed, when they don't have the time, but also when they don't know about other design patterns so that they can organize the code a bit better. So it's important to know when this is actually useful and when this is just maybe a distraction or a fancy solution to a problem that you didn't have in the first place. So make sure you open the source code and do the skill builder exercises to truly master how to build the mediator pattern. Let's look at a few real-life examples of using mediator pattern in JavaScript. The first one that I found is this a bit older library, JS Mediator. So it's probably not the best library to use, but we're just talking about the inspiration here. And it says in the name here, and does explained here in the documentation, but here it is connecting together authors' posts and comments so that when some functionality happens, it will know what to do with them. So in this case, in groups and connect something, and I don't really know what is going on about here, but we can see that it's orchestrating how things are going to happen so that when menu is clicked on the item authors, then it will render blog posts, for example. So it's connecting several objects, different objects at the same time. It also talks about this orchestration of different buttons. For example, when a button is clicked, something should happen with the router. There should be some navigation. Another example that I found is this Mediator, which is an easy-to-use library for implementing mediator pattern. It is in TypeScript. It does something similar. And here we would create and pass in the create person handler so that we can connect that person with sending a message, so some type of message handler here. Now this pattern, I feel, has been replaced by some other organizational patterns here, but you could still use it in smaller applications here and implement maybe some of these libraries based on the complexity and the needs you might have. Let's do a quick summary of the mediator design pattern. Do you remember which problem it solves? We talked about issues of many components talking directly to each other. And when we have multiple components calling each other directly, our code becomes messy very quickly. The mediator pattern is used in different forms. It's found in many frameworks and some big applications that allow us to combine multiple components and objects to work together. Now, many user interface libraries and forms, pop-ups, filters, and graphs actually use some form of mediators to synchronize changes and events. And as soon as our application starts growing from several independent components or several unrelated modules into something that needs some sort of synchronization, some sort of glue between components, we are going to need some sort of mediator to take that responsibility for orchestrating what is going to happen with each component. This pattern resembles the observer pattern. The main difference is that in the observer pattern, the components decide themselves their own behavior, but the mediator takes the active role in making that decision. It acts as a controller between different parts of the application. Now, do you remember some of the benefits that we talked about in the mediator? We said that because components are now not talking directly to each other, they're not coupled, thus they are decoupled, right? So decoupling is one advantage. It makes components quite easier to reuse, maybe test and maintain on their own, maybe move to different applications, right? The second benefit is some way of centralized logic. We said that it's much easier to find what you're looking for when you know that it's in a mediator rather than maybe hunting around between all individual components, which are all in their own modules and they're all somehow interconnected. Now, the third benefit we said is extendability or extensibility, because we can add new components and new features and just hook them into the mediator without the need to change existing components that are now separate in our application. But do you remember some of the trade-offs, some of the negatives that we mentioned? We said that it's easy to create a huge overhead because for smaller application, this will only be some extra work. There is no need for that code if you actually don't need it, right? The second trade-off is a bit difficult debugging, and that is because even though components are now separated and easier to test individual, meaning it's easy to test a component on its own, it's a bit tricky to trace which mediator did what if our application is not very clear, if our code is not very clear and good organized. Now, another trade-off that we talked about is complexity shift. And that can happen just because we are now taking complexity from individual modules and jamming everything into the mediator. And it can become huge and it can become difficult to work with. So we need to have some way of structure and predictability and hopefully clean code inside the mediator itself. Otherwise, we have just moved the problem from our components into another file and called it a design pattern.